Hello friends, welcome back. I am Rajneesh and today we are going to discuss about logical volume management. Before understanding it, I would like you to go through the conventional disk management that was used before LVM came into picture. So it had some drawbacks, and the biggest drawback was that you cannot resize a partition. For example, this is your first disk, this is your second SCSI disk. So this is going to be your SDA, this is SDB. We created three partitions on it: div SDA1, div SDA2, div SDA3 of different types. This is ext3, ext3, and swap partition. We created one partition on dev SDB, which is dev SDB1, which was mounted under /opt. Now, in this scenario, what happens if your root partition is completely filled up? You have few options. You can remove unnecessary data from it. You can just move some data from it to /opt partition and create a soft link to it. But there is no feasibility that you can resize the partition. There is one more option in which you can add one more big disk, create the partitions, create the root partition with a bigger size and move your data to the new disk. So effectively, online resize is not possible at all if you are talking about conventional disk management. Secondly, if you have this disk of around 200 gigs of size, your root partition or any of your partitions cannot be bigger than 200 gigs because it cannot span across multiple disks. But if you are talking about LVM, that's possible. Okay, now coming on to logical volume management. Before we start with it, you'll have to understand a few terms. First is physical volume. Physical volume is a name that is assigned to any physical partition or any physical disk which is a part of this logical volume management. So the first thing that needs to be done is we have to create a partition or allocate the complete disk as a physical volume. After we have created physical volumes, we group them together to create a volume group. Okay, in this example, we have three 200 gigs of hard disk. First, we create a physical volume on it, physical volume on the second disk, and the third disk. Now, after you have created physical volumes on these disks, they are ready to be added to volume group. So you add these three physical volumes to a volume group. So finally you have a volume group or a virtual disk which is visible as 600 gigs. Now you can create a partition using this 400 gigs. You can create partition that could be up to 600 gigs in size. Okay, so after this volume group is created, you cut slices out of it and create multiple partitions, as can be seen over here. Physical extent is the smallest part of the physical volume that can be allocated to a logical volume. This is logical extent, and the size of logical extent is exactly the same as physical extent. Logical volumes are created out of logical extents. So it's a combination of logical extents. And logical volume should be, the size of the logical volume should be in multiple of logical extents. By default, it's 4 MB. It means by default, it's not possible that you can create a logical volume of 2 gigs or 6 gigs. It should be multiple of the size of logical extent, which is 4 MB. Okay, now you have created these three partitions /opt/var/home. What happens when your where partition is completely filled up? One option is you can reduce the size of your home partition if you have free space in it. You can reduce it after unmounting it, and after you free up some space from slash home partition, that space can be allocated to where partition, and effectively you were not required to add any new hard disk, and the size of your where file system where partition grows up. So this is online growing up of the size of a logical volume, and we reduce the size of logical volume home without formatting it. So this means that we are able to resize these partitions. What happens when this complete 600 gigs is used and you want to add some additional hard disk to it, or you want to increase it to 800 gigs? You can get a new hard disk, attach it to the server, you can mark it as physical volume, you can increase the size of volume group, and after the size of the volume group has been increased to 800 gigs, you can increase the size of any of this or all of these partitions by the required value that we are going to see in the lab. Coming on to the features of logical volume management, the best and the most important feature is you can resize the volume groups. How to resize? You can increase the size of the volume group by adding hard disk. You can reduce the size of volume group after removing a hard disk. But in case you are planning to reduce the size of the volume group, the most important thing that is to be noted down is make sure that the physical extents of that physical volume are not used in the volume group, otherwise you may corrupt your volume group, that is losing all the data on the logical volumes effectively. So you need to be very careful when working on it. You can reduce or increase the size of volume group. You can resize the logical volumes, means you can increase the size of where partition, increase the size of home partition, or decrease the size of these partitions. You can create snapshots. It simply means that you can create a snapshot or the state of all the files in the logical volume at a particular instance of time. You can take a snapshot at around 2 a.m. or 4 a.m. as per the server time, and the status of that particular file system will be saved. You can get back to that particular snapshot and you will have the exact data on the server that was present in at that particular instance of time. So that is snapshot, the state of a file system at an instance of time. On LVM1 it was read only, but in LVM2 it's read write. Now if we are talking about creating logical volumes out of physical volumes, it can be done in a linear fashion that we have displayed over here. Firstly, these three logical extents will be mapped to three physical extents. After that, so on. Each one is mapped to the same sequence. This is linear logical volume or the linear mapping. Second one is mirrored, which says your physical volume 1 is mirrored to 2. Whatever you write on physical volume 1 is going to be replicated or mirrored to the second mirrored volume. Striped means first physical extent that I use is this one, and then this one is used. If I'm creating a logical volume with three logical extents, the first is going to map with this one, second is going to map with this one, and third is going to map with the first one of third physical volume. The same happens for the other logical volumes. So the mapping is happening in striping. First physical extent, first physical extent of this will be used, then first of third one. Then coming on to the fourth logical extent will map to this one, fifth is going to map with this one, and sixth is going to map with this one. This is striping. So this has some benefit that in case you are trying to access the data which is present continuously, so you can access the data in parallel and it is going to be faster in read and write. So finally you can move logical volumes between physical volumes. So we'll see all the details in the lab. Coming on to the lab now. To demonstrate this, we have a virtual machine which is desk 8. Let's start with the physical volume, which is going to be your base for the logical volume management. So this is the most underlying part. PV display is the command that can be used to display all the physical volumes present on your system. So PV display says for physical volume name, which is PV dev SDA2, the volume group with which it is attached, that's VG underscore desk8, the size of the physical volume, that is the size of the disk or the size of partition. So around 3 MB is not usable because of the size of physical extents. Minimum size of physical extent should be 4 MB. Allocatable or not? Yes. Physical extent size is 4 MB. So that's the reason here you can see that 3 MB is not usable because this is less than 4 MB. Total physical extents, this is the count of physical extents present in this physical volume. Okay, 1229 into 1229 is the count of physical extents, and 4 MB is the size of physical extents. So into 4, sending it to BC. Sorry, yeah, BC is not installed. Let me try it on my base machine. So this is going to be 4916 MB, and if you divide it by 1024, it comes out to be nearly 4 GB. Okay, actually we are missing some parts. Scale is 2, so because by default it doesn't display anything after points, so it's 4.8 gigs. I set it to scale 2, means 2 numbers after full stop, or 2 numbers after this part. Got it? So this is now 4.8 gigs in size. The physical extents that have already been allocated or used, this is 1229. Okay, now if you want to see it in a summary in a single line, you can see your physical volumes like this. This will list all the physical volumes if you have more than one. So this is exactly the mapping of the same attribute. A says allocatable or not, but full, so it's fully utilized because the allocated physical extents is same as total physical extents. Okay, coming on to the next part, which is going to be VG display, which displays you all the volume groups that are present in your system. So here it displays you the name. If you want to see it in the short form, VGS command can be used, which displays you the same details of all the volume groups but in a single line. So if you are talking about multiple volume groups and you want to see all of them, so it's more understandable if you use VGS. So format type is LVM2, metadata areas VG access. We can write on this volume group, we can read this volume group. Volume group status, it's resizable. So here Z says it's resizable, W says it's writable. Maximum logical volumes is unlimited. Currently the number of logical volumes is 2. I'll show you. Here one is root, other is swap. They both belong to the same volume group, so it's displaying it as 2 logical volumes which are currently present on it. Maximum physical volumes that can be added to it, it's unlimited. Currently the number of physical volumes attached to it is 1. Here you can see there is only one physical volume attached to it, and actual physical volumes that it has is 1. Physical volume, volume group size is 4.8 gigs. Physical extent size is 4 MB. Total physical extents, that is 4.8 divided by 4. If you are talking about the size in MB, so it's 4.8 into 1024 divided by 4. That comes out to be around 1229. Allocated physical extents or allocated size, so 4.8 gigs, it's completely used. Free physical extents is 0, means we cannot create any more logical volumes out of it until we add some more physical extents, because all the physical extents have already been used. Okay, so finally coming on to LV display, which displays you all the logical volumes present on this system. So this is the path, name of the logical volume, the volume group from which this logical volume is created, whether it's read write, it's read write, the machine on which it was created, the status, is it available, yes, size 512 MB, current logical extents, that is 128. If you are going to multiply it by 4, you'll come to know it comes out to be 512 MB. So logical extents is 128 into size of each logical extent is 4 MB. That comes out to be a logical volume size. Segments 1, allocation inherit, read ahead sectors. Okay, these are the block device details. Okay, so after looking into the generic details, we are going to create a new volume group now, or we are going to create a new partition out of it. First thing that we need to do is we need to have a look into the physical disks that are present on the system. So fdisk minus L is the command that lists you all the disks. Here we see that first is dev SDA, which is around 5.3 gigs, but it's already formatted. Dev SDA 1 is formatted with ID 83, which is corresponding to Linux. Dev SDA 2 ID 83, ID 8E stands for LVM. So this is a partition of type LVM. Now second one is dev SDB, around 104 MB in size, but it doesn't have any partition associated with it. The same happens with dev SDC and dev SDD. So the three disks dev sdb, dev sdc and dev sdd are blank. If you want to look into the size, 100 MB, SDC 200 MB, and this is again 100 MB. So we are going to use these three disks to demonstrate how an LVM works. Okay, so first thing that we have to do is we have to let the logical volume management know that this disk can be used as a part of logical volume. So first thing we are going to do is pv create dev sdb. So what happens this time is it creates a physical volume dev sdb. Now after this physical volume is created, it's ready to be assigned to any volume group. So pv display dev sdb. Here it shows you the details of dev sdb, the size, physical volume size, which is 100 MB, physical extent size is right now not there. So physical extents will be created as soon as I create a volume group out of it. Got it? So physical extent part is completely free as of now. So initially you can create a volume group out of a single physical volume also, but we are going to use two. So okay, first thing is we pvs, so it displays you dev sdb is now a physical volume and ready to be added to any volume group. Let me create one more, pv create dev sdc, and pvs says dev sdc is now a physical volume. Now we have created two physical volumes. These two physical disks are ready to be allocated to any volume group. So let's create a new volume group. If you want to see the help, vg create minus minus help is the minus minus help is the command. Whether you want to do auto backup, whether it's clustered, you want to debug while running the command, help minus L, maximum logical volumes that can be created in it. By default it's unlimited. Metadata type could be 1 or 2. Minus T is just to test, and minus V is for verbosity. So the most important part is volume group name. So let's create or assign it a name VG test, and the physical volume paths, whatever physical volumes we want to attach to the volume group which is VG test. So dev sdb and dev sdc. So what this command is going to do is it will use the physical volume dev sdb and dev sdc, combine them together, and will create a volume group VG test. So VG display VG test. Now it displays you that we have a volume group VG test. Maximum number of logical volumes that can be created is unlimited, and currently it's 0. Open logical volume. Okay, other important part is volume group size, which is around 300 MB. Why? Because the size of dev sdb was 100 MB and dev sdc was 200 MB. Now you can see the physical extent size. By default it's 4 MB. So if we divide 292 by 4, you will come out to be 73, which is the count of physical extents. Now if we type the command pv display, now you can see that here you can see physical extents size. After you have created a volume group, physical extents are created out of them. So each is of size 4 MB and total number of physical extents sorry yeah, I was looking into dev SDA 2, but in this lab we have worked on these two. Okay, so total physical extents is 24. 24 into 4 comes out to be 1696, around 100 gigs. So it says not usable is 4 MB, so comes out to be around 96 MB, which is utilizable from this dev SDB physical volume. And these physical extents size, total physical extents, and yeah. Now the other thing that you see is number of free physical extent. It means the number of physical extents that can be assigned to any logical volume. Till the time you see allocated physical extents is 0, that physical volume can be moved out of volume group safely. That's important part if you are trying to reduce the size of volume group. Okay, so till now we have created physical volume, we have created we have created a volume group which is VG test. Now we need to create a partition on it, so or a logical volume on it. Okay, so lv create is the command that can be used to create a logical volume on which the actual data is going to reside. Let's run the command -help to see all the options. So if I'm creating a generic logical volume partition, I'm not using all the partitions. I would rather like to use the name. Here you can see it. Let me give it the name test. Permission, whether it's read only or read write. T is for test. So finally, physical volume path. Actually, logical volume is created from volume group. So dev vg test, or it could be vg test. One moment. Dev okay, we are missing one more part, which is capital L if we want to use the size in kilo, mega or gigabytes, or small l in case we want to use the number of extents that we have to assign to it. So let me create it for around 50 M as of now out of VG test. So what this command did is I created a logical volume with the with the name test, with the size 50 M, rounded off to the multiple of 4, which comes out to be 52 MB, and it was created from the volume group VG test. Now I just ran the command VGS. Here I can see volume group VG test. The number of physical volumes attached to it is 2. Here you can confirm it. Dev SDB and dev SDC are attached to it, and the number of logical volumes inside it is 1. Here is the logical volume test that I just created, and it's present inside volume group VG test, and the size is 50 M. So now we have a logical volume test which is ready as a partition, and we can create or format it with a particular file system, and it will be ready to put the data on. So I am going to create an extended for file system on this logical volume. So here I give the complete path, div, then volume group name, and then logical volume name, and I format it with the file system of type extended for. Now if you want this partition to be available after every reboot, you should make an entry in etcfs tab. First entry says which is the partition that is to be mounted, or which is the file system that is to be mounted. Second says which is the folder on which it should be mounted. Third option says which is the type of file system present on it, which is extended for, and fourth specifies the options that you want to provide it. Fifth and sixth are for dump and the fsck, the sequence at which the fsck is to be run on this file system, if it's required to be run. By default it's 30 days, or I think I've forgotten the number of days. You can specify the number of days after which the fsck should run on a file system, or you can specify the number of mounts after which the fsck will be forced on a particular file system. So I specify this is the file system that is to be mounted on /test folder. So before that we'll have to create test folder also. mkdir /test mount /test. Okay, so bad super block. It means there is some mistake. And I can see that superblock and file system counting information was written. Here you can see the file system will be automatically checked after every 32 mounts or after every 180 days, whichever comes first. Tune to fs can be used to change it. Now coming on to, we created a file system of type ext4 on it. I suppose I should be able to mount it. -t ext4. Let's try to mount it through the command line and see what's the mistake that I am doing. df-h. So I can see it's mounted, so maybe there is some issue with my entry. File system, where it's to be mounted, so /test is fine. Third option is okay, ext4, which is the file system. What my mistake is, it should be defaults instead of default. umount test and mount /test df-h. Here you can see that now it's getting unmounted and mounted successfully. And the most important thing that we need to make sure in case you are appearing for Red Hat examination is after you reboot this machine, that file system should be automatically mounted to the desired folder. For example, in this scenario, it is going to be mounted at /test folder. So here is how it's getting booted up. Why we have rebooted? Just to make sure that it gets mounted after every reboot of the server. Okay, come on. Now df disk free df minus h is the command that can be used to see all the file systems that are mounted, and here I can see that it's mounted under /test, so it's perfect. File system was available after the reboot of the machine. Now in the next exercise we are going to increase the size of this partition. Right now I can see that its size is 51 M. What in case it gets filled up? I may have to increase the size to 100 megs, and this is what I am going to do. So first thing that we have to understand is, what is this? This is a logical volume. So there should be some command like lv extend minus L. Capital L stands for the size in megabytes or gigabytes that you want to add it. So I want to add additional 12 megs to it, or let's say I want to add additional 50 megs to it. To which one? Dev mapper vgtest and test. Now here you can see that extending logical volume test to 104 megs, right? LVS. This command shows you that the size of the logical volume is 104 megs, but this size is not yet visible to your file system /test. It's still visible as 51M. The reason being, the file system doesn't know that the back end or the volume group has been increased from 50 to 100 megs. You have to tell the ext4 file system on it that the size of the logical volume has been increased. How do you tell it? So for that, resize to fs is a command that can be used to increase the size of it. If you are using this command, you can resize it to a particular size. If we see minus minus help, it says okay. After this, if I say it 75M, so the size of this test partition is going to reach to 75M. If I don't use the new size, by default it occupies the complete space available to vgtest, which is now 104 megs. So I just run this command. Now it's performing an online resize on this, and the size of now vgtest has now grown to this much of blocks. And if I see the command df minus h, here I see the size of the test partition is now increased to 100 megs. So what would we do? we increased the size of logical volume using LV extend, and secondly, we extended the file system, or we resized the file system to the size of that logical volume. So resize to fs was the next command. So here is how we extend the size of a logical volume. Now, okay, VGS, volume group test. Here we can see that we have around 188 MB of volume group, or around 188 megs of space is still free on the volume group test. So if I want, I can create a new logical volume on it. LV create minus L 188 megs minus N is test2 from VG test. A volume group name, path required for logical volume test2. Sorry, actually I was creating a new volume group. Test2 is a new logical volume, so LV extend will not work. So here test2 logical volume is created. Now LVS displays that you have two logical volumes, test and test2, under VG test. VG display says you have no volume free. Now you cannot add any more logical volumes to it. Reason being, you don't have any free space. Now what if I need to increase the size of the test volume? One option is I just remove test2. The other option is I add a new hard disk to it. So what I am going to do in this scenario is I am going to add a new disk to it and increase the size of the test volume now. First thing is pv create dev sdd. So before that, what I did was I have added a new hard disk. I know that we have a new hard disk SDD which is free and which has nothing on it. So I am going to prepare it to be used for volume group. So pv create is the command that prepares it to be added to volume group. Second part is I am going to extend VG test. How do I extend it? By adding a new physical volume to it. Now if we see VGS, it displays you that we have around 96 megs of disk space free in the volume group. Why? Because we just added one more physical volume to it. And here you can see that dev SDB, dev SDC, dev SDD are now the part of the same volume group VG test. Okay. PV display, it says that total physical extents are 24 and all of them are free on dev SDD. Free extents on dev SDC is 0 and on dev SDB is 0. Reason being, we have already created logical volumes out of them. So now the final objective that we are going to achieve is we want to increase the size of this VG test partition from 100 to 150 megs. So we are going to run the command lv extend minus L plus 50 megs dev mapper vgtest and test. It's able to increase the size because we had some free space in volume group. So if I see it now in the VG test, you can see that the free disk space has been reduced to 44 gigs. Previously it was 96 gigs. So effectively 50 MB has been taken out of it. PV display dev as dd. If we see into the physical volumes, I can see that it has total 24 physical 24 physical extents, out of which 11 are free, 13 are allocated. So these 13s have been allocated or added to LV test. Okay, now if I still type df minus h, I can see that the size displayed is still 100 MB. However, LVS says that the size of test should be 150 MB. So the final command that I am going to write is resize to fs, which resize my partition to 150 megs. Rounded off to a multiple of 4 comes out to be 152 megs. So in this way we increase the size of a logical volume. Coming on to the next part, in which you want to reduce a size of physical volume. Now till now we can see that the size of the size of the logical volume is 150 megs, and we want to reduce the size to 100 megs. First thing that we will be required to do is reduce the size of the data in it, or you can say that the reduce the size of file system on it. So file system knows that I have data in around or less than 100 megs in it. For that, first thing I am going to do is umount test. Now it's ready to be resized because I want to reduce the size, so it's good to get it unmounted. Now we should run fsck on it forcibly. It says it's clean. E2 fsck has one more option which says run even if it's clean. Assume okay, minus f, force checking even in case the file system is marked as clean. So I am going to run fsck forcibly on it. So fsck is run, first part is done. Secondly, I know that the data that I have on it is less than 100 megs. So I am going to resize the size of this file system to around 90 megs. Now the size of the file system has been reduced to nearly 90 megs. Now the final part that I am going to do is I am going to use lv reduce command mapper vgtest test. So finally what I am going to do is I am going to reduce the actual size of the logical volume. uh, okay, it says gives you a warning reducing active logical volume to 100 megs. This may destroy your data. So do you want to reduce? Let's say no. We should rather mark it as inactive. So LV change minus A, whether active or not, mark it as no. Dev VG test and test. So now this volume group is no more active. So here you can say that A is removed, or the other command is LV display test. So here, yeah, can you see something like active? No. Okay, compare it with LV2. LV status is available, and here LV status, you see it's not available because it's not active now. Now let's try to reduce the size. And here we have reduced the size by 50 gigs, and it has come out to be around 108 MB now. After the size has been reduced, we can run resize to fs once again on it. Yeah, the reason it didn't run was lv change minus a y, so it's going to mark this logical volume as active now, and now I resize it. So whatever free space was available on logical volume test is now ready to be used. Now I just mount test and df minus h. So here I can see that the size of the logical volume is now decreased from 150 megs to 100 megs. So this is how we reduce the size of a logical volume. If we recall the steps, step 1 says unmount the partition, or one moment, history. Okay, so first part was we unmount the partition, we ran the fsck forcibly on it, then we resized the file system size on this logical volume to less than 100 megs, which we marked as 90 megs, and then we reduced the actual logical volume by 50 megs. And before reduction we had an issue that it was marked as inactive. Okay, sorry, we tried to reduce it, but it gave us warning that it should not be reduced in size while it's active, so we just marked it as non-active by using minus a n, and then we reduced the size of it, ran. Okay, we had to mark it as active, and then we resized it and we mount test partition, and we can see that the size of the logical volume is reduced. So we have understood LV reduce, we have understood uh, LV extend, VG extend. Now we need to understand how to move a physical volume out of a volume group and get it replaced by a better disk or a better physical volume. So if we run the command vgs, I can see that the the disk space which is free is 92 megs, which is not sufficient, because if I type PVS, I can see that my physical volume, any of the physical volume, is more than 96 megs. So okay, let me reduce the size of VG test 2 by 50 megs. I don't have any data on it, so let me just mark it as inactive. LV change minus n minus an. I have not yet formatted this test 2, so it doesn't matter running the resize 2fs command. So lv reduce minus l minus 100m. Okay, so now I mark it as active. PVS VGS. Now in the volume group VG test, I can see that there is nearly 200 megs of disk space free. Fine. If I look into PVS or div SDC, it says out of 200, around 100 megs is free. Div SDB is completely filled up. Div SDD, around 92 megs out of 96 is free, but 4 megs is still used. So we cannot yet remove SDD out of the volume group. Okay, now the objective is we have to remove div SDD out of this logical volume, out of this volume group. The reason being, the div SDD disk is very old and I need to get it removed and replaced by any other disk. So how do I do it? First thing I do is pv move is a command which moves your physical extents from a disk or a physical volume to a different volume. As pv move minus minus help, so it says source physical volume and then destination physical volume, PVS. Okay, so PV move dev SDD, we are going to move or all the extents that are being used in dev SDD will be moved to dev SDC. So dev SDD is going to be free after this command runs completely, and it'll be ready for the removal. Let the command complete. Now if you write command pvs, here you can see that all the 96 MB is free on dev SDD. Now PV, before you remove that, we need to reduce the size of volume group or take it out from the volume group. VG reduce minus minus help, VG test and dev SDD. So now if you see VGS, the size of the volume group is now reduced. Oh, one moment. What was the size of the volume group previously? One, yeah, one is 100 MB, other is 200, and the final is 100 MB. So, but still there is one thing, that is dev SDD. It's not assigned to any volume group now. PV remove to clear all physical volume related metadata from it. Now div SDD can simply be removed from it, and if you want you can add a new hard disk to the volume group by using VG extend. So I think with this we finish up the basic concepts of logical volume management. I would be waiting for your feedback, and please let me know if you didn't understand anything so we may explain that in a better way. Thanks for viewing the video. Have a good day.